Hello, student. In this lecture, we're gonna talking about two sections. One, we learning how briefly measure the voltage and the current, and then we how to make circuit analysis when we have the complex circuits. Measuring the voltage and the current, we use it for that a digital multimeter or DMM, and the only difference we wanted to clarify. When we measure the voltage, I need to set my digital multimeter to the volt setting, and when you measure the voltage, you don't have to interrupt your circuit. You just hooked up the two terminal of digital multimeter across your element. So on this one is circuit. I want to put it in parallel with my element and reading the voltage here. And that's different when we measure in the current. You measure in the current, we need to disconnect your circuit to measure the current through the any part from your circuit. So in this case here is my current goes in this way here. I make the disconnected here to hook it up my digital multimeters and the output connected. So basically the circuit connected through your multimeter. And here we read the measure in this branch, which is basically the measure through the circuit or the measure in the resistors. And here give you an example here. In the practicals, we have small batteries connected to the resistors, and which one, if you want to measure your ampere, or you want to measure your current, which one is the right connections? Again, so this one's the right connections. Since I need to measure the current, I have to disconnect my circuit and hook up my ammeters. So let's now move to the second one or second sections. When we have the circuit, how we're gonna deal with the complex circuit. We have here is the four bulbs, and they are connected, and they ask you to rank the brightness of the light bulb from the bright to the dimmest. Okay. So to imagine this circuit is in easy way. So let's draw it in the way we can easy to observe. So I have the first branch here. This is the first light bulb. Then the first one, this one A, and this one is B. And then this branch here is C. And then both go to the D and connect it my circuit. So this one is the light bulb. Again, the light bulb, all of them, they are identical, unless they mention something different. Otherwise, we assume the light bulb, they are the same resistors. That's what I mean by identical. Now, let's write it down, or let's rank our brightness. So the brightness based in the current goes through the resistors. So the current here, this is the main current for the circuit, and this current is gonna go to this way and go to this way. So in this part, you will face the C bulb line, and here we have B and A. So basically, depending about the resistors, here is the two series resistors. I end up with the larger resistors, equivalent one. So RA plus RB, larger than the RC. So again, the current, when we have two resistors, they had a tendency to go through the resistors. So here the current, most of the current, we go to the C. Okay, not go to the A and B. Regarding for the A and B, they are connected in series, that they have the same current. Then the current comes from the C and the current from the A and B connected in the same node, Kirchhoff junction law, they're gonna go out to the D. So from here, I can see the D, it's the largest bright because it has most of the maximum current go through it. And this one larger than, the second one should be C. So since the current through the branch C larger than B and A, and this one larger than A, but what the relation for the A and B? since they are connected in series, they have the same current. It should be they are equal. Okay, so that's the rank the brightness. So let's move to the second problem here, which you need to read your value, and from your value, you need to draw or imagine how's your electrical circuit connected. Now we have 3 resistors or 3 light bulbs connected together and provide you just the value of the difference potentials and the current. So in the case like that, you just look at the voltage and the current. Wherever we have the same current, indication to I have series connections. Wherever I have equal voltage, means I have parallel connection. So if you look at the circuit here, the circuit comes from the current comes from the battery. The same in the R1, the same go through the R3, the same pass through the R2. So I have the same current. What's that mean? The only case I have the current the same, and when they have the resistors, they are connected in series. So here is my battery. And how much the battery here is 36 volt. I have 3 resistors, R1, R2, and R3 should be in parallel. I built this one based in the current value. They have the same value. Anything else, I have nothing else. So here is the R1, and here is the R2, and here is the R3. And here is, if you want to do it, delta V1, delta V2, delta V3. Where is my delta V1? In this case here, the voltage across the resistance R1, which basically here is the 9. Delta V1 equal 9 volt. Delta V2 equal 15 volt. And delta V3 equal 12 volt. Delta V, which from my source equal 36 volt, which should be equal delta V1 plus delta V2 plus delta V3. This one condition should be satisfied based in the Kirchhoff voltage law. So that's how we connect the same. The second circuit here, it's gonna be the same, but the only thing here, the current have different value, but the voltage has the same value. So basically what I have here, I have parallel connections. And if you look at for the current for the parallel connections, the maximum current should be go through the least resistors. If you look at here, 2 amps, it has 12 ohms, with the maximum resistors has lowest value. What the minimum current, minimum resistors, 3 ohm, it has a maximum current. So just to keep it in your mind. Again, the delta I, or the summation of the current through the 3 resistors, should be equal 60. So this circuit is just basically parallel connection. Let's move for the second one. Second example. You are asking to write down the summary for the circuit or for the light bulb based in the current and before and after we close the switch. So again, those 3 bulbs, they are equal. So let's assume their resistors, they are R, just to make it easy. So they are equal. So let's go for the first one. So the first one, since the switch, it is open, I have no current here. So basically my current goes this way. The equivalent resistors R, it will be 2R. My current, it should be E divided by 2R. So the current here, current through the A, since they are in series, the same current through the B. So here I have half E divided by R. Current through the B, the same thing, half E divided by R. What the current through the C? It is open, so this man, 0. Don't confuse. Ask you for the total current. You cannot make the summation for those. The total current, it is the same current since I have a series connections. Let's see after we, second case here, we close the switch. And now what we have, if you look at this is the first case. The second case, when I connect it, so basically it's the R for the RA, let's be clear. RA series with RB, RB parallel with the RC. Again, RA and RB, they are equal R. So you end up with the R plus half R, because they are equal resistors. When they are equal resistors connected in parallel, the equivalent resistor is half of the resistors. So I end up here with the 3/2 R. To find, now this is my equivalent resistors. To find what? To find my equivalent or the total current. The total current should be E divided by equivalent resistors. 3/2 R, which basically you end up with the 2/3 E over R. So that's the current. Where that current? This is the total current. The total current is the same current go to the A. So I have this one, it should be 2/3 E over R. Now what about the C and B? Since the two resistors, they are equal, the current will be divided equally. So what's that mean? I have here will be 1/3 E over R, and for the C, the same one, 1/3 E over R. Again, because my two resistors that are equal, the current will be equal. Regarding for the total current, it is the current through the A, or the current comes from the source. So here is the 2/3 R. So here you can compare with your bright. So your light bulb A, it was in the previous, before the switch on, it has a half, and then it increased by 2/3. So here is the more bright. And for the B, it was half and reduced to the 1/3. So this one less bright. Okay. And for the C, it was off. Now it is turned on, and what had a bright is the same as B. Okay. So I am done with this part, guys, and see you in next video. Thank you.